Welcome to Fast Math Solutions on Maths with EJD. In this video, we'll be looking at this problem. The real part of a complex number is 1. And the imaginary part is also 1. Express this complex number in rectangular form, exponential form, and polar form. These are 3 forms in which complex numbers can be represented. So let's dive into it. The question again, the real part of a complex number is 1, and the imaginary part is also 1. Express this complex number in rectangular form, exponential form, and polar form. Okay, let's see that. Okay, now in rectangular form, right? We are told that the real part is 1, that A is 1 and B is also 1. So that's something like 1 plus 1i, all right? That's what that is. So if you put it into a graph, you have the real axis, you have the imaginary axis. On the real axis, it's 1, like this. On the imaginary axis, it's also 1. So you have one that is A and you have one that is also B. So in rectangular form, you have Z equals 1 plus I, or if you like, something like this. Z equals 1 plus 1i, which is, of course, 1 plus I, like you have up here. So this is it in rectangular form. Rectangular form talks about the Cartesian coordinates, something that looks like the X and Y axis kind of thing, right? So that's the rectangular form. Now, in exponential form, generally, right, the exponential form is something like Z equals RE raised to power I theta, which leads to the Euler formula, right? Which is the Euler formula technically. So in exponential form, we have Z equals RE raised to power I theta, where R is the magnitude and theta is the argument or the angle, all right? So, right from here, you can even still say this is actually the theta and this is R now. The magnitude R and the angle theta. Okay. So how do we get the R? You get R by taking square root of A squared plus B squared. And here our A is 1 and B is 1 because we are dealing with Z equals 1 plus I. Okay. So A is 1 and B is 1. So R is square root of A squared plus B squared. And that is square root of 1 squared plus 1 squared. That's square root of 1 plus 1. That's square root of 2. So this is the magnitude. Then talking about the argument or the angle, theta. So it's generally obtained by taking the inverse tan of B over A. B is 1 and A is 1. So arctan of 1 over 1. And arctan of 1 is equal to 45 degrees. And 45 degrees in radian is pi over 4 because pi itself is 180 degrees. So you can actually say that in exponential form, Z equals 1 plus I is the same thing as square root of 2. That's your R now. E raised to power I pi over 4, and that is it in polar form. So this is it right here. Okay. So the last form you need is, that is it in exponential form. Sorry. The last form you need is the polar form. And once you have the exponential form, the polar form becomes pretty easy to handle. So in polar form, right, we have Z equals RE raised to power I theta, and that's exactly the same thing as R into cos theta plus I sin theta, which is the Euler formula, such that in this case now we have Z equals root 2 e raised to power I pi over 4. That is the same thing as root 2 into cos pi over 4 plus I sin pi over 4. If you also like, you can make it in degrees, so you can say root 2 into cos 45 degrees plus I sin 45 degrees. And that's how that goes. So that's what we are required to do as far as this problem is concerned. See you in the next video. If you have not subscribed, make sure you do that and hit the notification bell so you can always get alerted when a new video is released. Thank you.